Hey there, today we're going to look at 4.5 on slope-intercept form. Our objective is to be able to use the slope-intercept form of a linear equation to graph the function and to model the real-world linear relationships. And this falls under two standards for us, FIF4 and ACE.2. And so let's look at this little explore activity here. We want to write an equation that has a slope of 2 and a y-intercept of 3. And so step one, this line has a slope of what? Well, it said a slope of 2 and a y-intercept of what? 3. Okay. So since 3 is a y-intercept, what ordered pair is a point on the line? Well, if the y-intercept is at 3, then the ordered pair would be 0, 3, right? So let's substitute these values into the slope formula. And so since we don't know any other points on the lines, we'll use a generic xy ordered pair. And so that's what we have here. So remember, m is equal to the change in the y over the change in the x. And so our m, which, what do we have for the m? Well, we said the slope was what? 2. And so we're going to get y minus what? Well, my y value is 3. And then x minus what? My x value is 0. Okay. And so now we're going to solve this for y. Now, they've got all the boxes here. And we're going to see how this manipulates across. So we got the 2 is equal to y minus 3 over x minus 0. The 2 will stay here. Nothing's going to happen to it yet. And we've got y minus 3 here. But x minus 0 is going to give you what? X, right? Now, my end goal is to get this y by itself. So what could I do to get the y by itself? Well, we can multiply both sides by the x. And when we do that, we're going to get 2x is equal to y minus the 3. And then what can we do to get this y by itself? Well, we're going to add 3 to both sides. And so we get that 2x plus the 3 is equal to y. And so in this equation, the coefficient of the x is equal to the slope. Because if we look, come back to the top here, what do we say the slope was? All the way back up here, the slope is what? 2. And when we get all the way down here to the end, the number that's attached to the x, remember that's what we call a coefficient, is also 2. So that hasn't changed. When we look at the 3, look what happened here. The 3 here is the same as the 3 that was here. That's the y-intercept. And so the constant is equal to the y-intercept. Okay? So what is slope-intercept form? So defining it, slope-intercept form, you'll see it written one of two ways. Most of you remember it as y equals mx plus b. Every time we talk about slope, y'all try to give me this instead of the slope formula. Remember, slope-intercept form is the equation of a line. And remember, if we're dealing with function notation, we might see as f of x is equal to the mx plus b. Remember that the y and the f of x mean the same thing. One just means that we're dealing with a function. The other is just an equation. Okay? So why can it be helpful to solve an equation for y? So let's say I was given something in standard form like 5x minus 2y is equal to 20, right? Why might it be useful to solve this for y? Well, I'll go back to the statement we had here, right? When we solve this for y, the coefficient of the x is the what? The slope. And the constant is the what? The y-intercept. And so why can it be helpful to solve for y? Because the coefficient of the x is the slope, and the constant is the y-intercept. Okay? So we're going to look at a couple examples with slope-intercept form to graph them. Again, this should not be anything too new, just recalling what we've done before. And so remember, you can graph a linear function f of x is equal to mx plus b. Remember, we could also have the y here, using only the slope and the y-intercept. First, locate the point 0b, our y-intercept, on the y-axis. Then we'll use the slope, the rise and the run, to locate another point on the line, and then we'll draw a line through those 2 points. One common misconception here is that we just connect the 2 dots and we stop. No, this is a line that continues through those 2 points. It continues on forever. So let's look at example 1a here. We've got the equation y equals 2x minus 5. So ask yourself, what is the slope and what's the y-intercept? Well, the slope is 2. And the y-intercept, don't forget the sign here, the y-intercept would be the -5. And so I'm going to go to -5 on my y-axis because that's my y-intercept. And then my slope, remember we want to relate this as a rise over run, so this would be 2 over what? 1. So I'm going to go up to right 1 and put a new point. Now I can continue that pattern up to right 1, up to right 1, and I can also reverse the pattern. So instead of up and right, I can go down and left, so down to left 1, down to left 1, and I start to see this line forming here. And that's it. And so remember, what the line represents is any ordered pair that I could plug in for the x and the y that would make this equation true. So like, for example, the ordered pair 3, 1 would make this true because 2 times 3 is 6 minus the 5 gives me 1. Okay? And so when we look at example B here, this is in function notation, but remember this is just your y, right? So f of x is equal to -1/3 x plus 4. So what's the slope and what's the y-intercept? Well, the -1/3 is my slope because it's attached to the x, and the b is the 4. Okay, so remember we're going to plot the b first, our y-intercept, because remember the slope just tells us the steepness of the line. If I try to graph the steepness of the line, this line could be anywhere on the graph. That's just defining how steep the line is. And so I'm going to go to 4 first, and then my slope tells me to go down 1 and right 3, because the negative we can associate with 1 but not both. I'm going to go down 1 and right 3, and down 1 and right 3, down 1, right 3. I could also put the negative with the denominator and make them 1 positive, and so I can go up 1, but a -3 make me go left 3, up 1, left 3. And so we see this line beginning to form here. Okay, so again, that's all it takes to graph these in slope-intercept form. Students try to make it so much more complicated than what it is. It's really not. Just understand that the y-intercept is the point that you know, and the slope is to define the steepness of the line. Now, let's look at a situation where we're modeling a problem here. And so we're going to look at a real-life situation. A pump is set to dispense chlorine from a full 5-gallon container into a swimming pool to sanitize the water. The pump will dispense the chlorine at a rate of 0.25 gallons per minute and will shut off when the container is completely empty. The amount of chlorine in the container, A of t, is a function of the time t that the pump is running. Graph the function A of t and write a rule for the function and state the domain and range. Now, there's a lot going on this problem, but understand this. Where do we start? So when we think about our y-intercept, we're going to think about where do we start the problem. Well, we started with a 5-gallon bucket of chlorine. So my y-intercept for this will be 5. Now, when we think about the rate, remember we talk about the rate of change, right? Which we relate that to the slope. Well, my rate is 0.25. But in this case, my 0.25 is decreasing because it's dispensing the chlorine. And what our function's understanding is the amount of chlorine that is in the container. And so that amount's going to be decreasing as we go through this function. To build this function, we're going to get that A of t is equal to the 5, that's our y-intercept, minus the 0.25, that's the rate at which the chlorine is being dispensed, times the time. Because remember, our variable is not x in this case, but t, and A of t is the amount of chlorine left in the container. And so let's plot this out. I'm going to start at 5, because that's my y-intercept. That's where I'm starting. And then to dispense at 0.25 per minute, right? So every minute I'm dispensing a quarter of a gallon. And so how many minutes would it take to dispense a full gallon? Well, 1 gallon would be a quarter of a gallon, 1 minute's a quarter of a gallon, and so it would take 4 minutes to dispense because this is 1/4, right? So my slope is going to go down 1, right 4. And so I can continue this pattern, down 1, right 4. Now, I got to be careful here. If you look, these lines are by 2, so this is 2, 4, 6, and 8. 1 and 3 is there. So I'm going down 1, right 4, down 1, right 4, down 1, right 4, down 1, right 4. So again, my boxes are not by 1s on the x-axis, they're by 2s. And my boxes here are by half. And so as we get that out, we're going to get to here. And so I'm going to connect those dots. Just ignore that little spike there. And so I'm going to connect these dots. And this is what we get. Because when the container is empty, is the pump still running? No. And so this is the graph. And so let's talk about the domain and the range. And we've done domain and range before, just re-emphasizing this point with this problem. So our domain, remember, is the x-axis is going to go between. Well, it's going to go from where? 0 minutes to how many minutes? Where does it end? 20 minutes. So t less than or equal to 20. And my range, I'm going to end up with 0 gallons in it, right? And we're going to go A of t here is our y. And where did we start? We started at 5 gallons in the container. So this is my domain range. This is the function. And my graph is here. So I've answered all the pieces, right? It said graph the function, write the rule, and state the domain range. So I've checked all those boxes. So that's what this lesson is. Again, it's not difficult if you read through the problems correctly. Think about your slope, think about your y-intercept. That's the key to using slope-intercept form, and that's the key to reading through these word problems to pull that information out. Again, if you think about that y-intercept as where you start, and your rate that you're given, your rate of change is your slope, and understanding if it's increasing or decreasing, then everything else would be pretty straightforward. And so if you have not done your words of the day, make sure you get your word of the day now. Your word of the day is slope-intercept form. Again, your word of the day is slope-intercept form. Make sure you put that in your Google form. Don't say, I don't know what it is, because the word of the day is the slope-intercept form. And so make sure you put that in, get your credit for attendance for today, because I do need to see that, because that tells me you've actually watched this video. So I hope you'll have a great day. If you have questions, make sure you join the Zoom session at 11:30 to 12:30. I'll be available then. And again, if that doesn't work, email me and we'll work something out. I hope y'all have a good one. See you later.